Good afternoon. Thank you for joining this session. As a reminder, at the end of the session, please submit your feedback in the app. And if you have a survey in there, you can redeem that for a free AWS branded swag item. And at the end of the session, you can also scan your badge up front here to get the slides directly after. At this time, I would like to welcome to the stage Steve Sofian, presenting on enterprise network architectures on AWS.
Thank you. All right, my name is Steve. I'm a solution architect with the public sector team. I've been covering the central government, GovTech, and various other government agencies. I'm also involved in the design of GCC for AWS specifically. So after the session, if you have any question on GCC, feel free to reach out to me. So AWS customers such as huge government agencies or central agencies have had to face challenges in terms of designing so-called highly scalable hybrid connectivity that meets security and compliance requirements. So this session today basically will dive deep into the AWS network architectures that is available for you to deploy and to ensure that you are able to have a highly scalable network architecture at scale. So this session basically it's about for someone who is designing network architectures on AWS, someone who has deployed VPCs in production environments, network architect or engineers who is interested in terms of designing AWS network services. Please do not expect me to go down to explain what is VPC, subnet, route tables, or what have you, or some of the AWS core services. The expectation that you will have known about it. So in order to talk about designing a scalable network architecture, typically there's 5 focus areas that we'll cover. One is the account strategy. How are you going to manage the account? Is it one single big account? Or you have multiple accounts under the AWS organizations? You're looking at the internal connectivity between these VPCs, and then external connectivity back to on-prem, to MPLS, to third-party SaaS provider. At the same time, you're also looking at network services that you want to put in place to protect the environment. Last but not least, you could be looking at multiple region options, which is typically not feasible for the government agencies in Singapore, but for other institutions like a school or IHL, probably they might have requirement to have multiple regions. So some of the common public sector requirements is that I want to have a secure network environment. I want to have to baseline certain guardrails or controls within my account, and I'm able to govern those accounts. And at the same time with that, I will come up with a baseline definitions that control all these accounts. So account strategy. So typically, very common, a customer has more than one AWS accounts. And within these AWS accounts, there could be one or more VPCs. So it's a balance between what makes sense to you, how you want to decide the segmentation between account and VPCs. Some customers has one big account, have many VPCs in a single account, or some customers have many AWS accounts with only a single VPC within each account. Right. So what are the factors that would so-called affect your decision? So one is, does all these accounts have trust each other on, or each account basically is an own individual tenant? Is the current network segmentation allows you to basically to connect to each other easily and seamlessly? And who owns the security and networking? Is it a centralized team, or each team has to manage their own? And last but not least, how are you going to scope the security? Is it to the whole account, or to the VPC level, or even both? So let's look at the different layers that is available. One, inside the account, typically you will manage using IAM users and roles and govern those users into what they can do within those accounts. And you'll be leveraging on security groups in terms of controlling the network traffic flow between within a VPC itself. So at the VPC level, so you'll be controlling using route tables. Am I going to allow traffic from private subnet to go to the internet? Or am I going to allow traffic from the internet directly to my private subnet? Everything can be controlled within the route table itself. And at the same time, I'll be able to govern in terms of additional layer of security using the network ACL, as such that I'll apply to the whole subnet just in case someone at the system level has chosen to use the wrong security group. So then subsequently, I have multiple VPCs now. I have one single VPC that has multiple applications. I have a single VPC that has a single application. And these are the things is that at the bottom layer, basically, those are the infrastructure configuration, as such that you control the route table, the network ACL, to make sure that the tenant itself will not be able to violate or even with a bad actor trying to open up certain ports, certain holes to the internet. So in terms of looking at separation of duties, we have come out to introduce AWS organizations. With AWS organizations allows you to centrally manage all the accounts and apply certain guardrails like service control policies on those accounts. As such, for example, I'm not going to allow a user, or particularly this account, to disable CloudTrail within those accounts. So you can apply service control policies on that. So typically, as customers grow, they start to look at some common services that I can apply to all my different projects. Could be a central logging, could be a central AD, could be a central SIEM. So this is where I start to look at to segment the different type of services across the accounts. So you have shared services account, you have a log archive account to centrally collect all the logs, because logs are basically confidential and you do not want it to be tampered with. You want to be encrypted and only accessible to certain individuals in the company. Then you have the security account. This is where your guard duty to collect all the different findings from the different accounts. Last but not least, then you have the network services account. So this is where you consolidate all the networking components into a single account or a single VPC. Let's dive deeper into that. So with AWS organization, there are quite a number of services that is aware of organizations. As such, for example, config, CloudTrail. As such, you are able to centralize the findings of config findings, all the CloudTrail logs will centrally collected, I'm able to do single sign-on with AWS organizations. I'm able to create service catalog, a catalog of IT products that's approved. And subsequently, I push on to all the different accounts as such that these spoke accounts will be leveraged on the service catalog to provision the infrastructure itself. How are you going to be able to do that? Basically, it's through something called Resource Access Manager. This is where you're able to share the different services like subnets, transit gateways, Route 53 resolver rules, and system manager. So customer has feedback to us in terms of we want an easier way to manage our accounts. And I want to be able to guide me to have all the best practices when I set up my account. So this is where we have launched Control Tower recently. It has been GA. Unfortunately, it's not in the Singapore region yet. But what it does, basically, it gives you an automated way of setting up AWS. There's a account vending machine in there as such that it will speed out AWS accounts with all the base guardrails enabled. We are able to apply certain service control policies on the different OUs, as well as giving you a dashboard of all the resources within that particular organization as such that if there's any resources that's not compliant. So let's look at internal connectivity. So when we look at internal connectivity today, basically, to communicate between VPCs, what you have basically is VPC peering. So it allows you to connect up to 100 VPCs. It supports cross VPC security groups, referencing. It does inter-region peering as well. Then, of course, recently we launched AWS Private Link. This is a one-to-many connectivity options as such that, for example, you have built a custom bespoke application, which is like, for example, an authentication service as such. You want to open it up to all the rest of the applications. You can actually enable it by enabling a private link using a network load balancer and share this across VPCs and across accounts. Then subsequently, we move into Transit Amazon VPC. Customers want to centralize the connectivity back to on-prem. I want to have easy way instead of having multiple VIPs, multiple VGWs spread across all my VPCs. I want to have a centralized transit VPC as such that all the connectivity back to on-prem is go to a central location. And of course, with that, we have launched Transit Gateway last year. This is many connectivity options. It gives you an easy way to manage all the routes. It's highly scalable. It's running off AWS Hybrid Plane, and it only costs based on per attachment basis. So let's look at starting point. This is where we start off much earlier, as such that we have a DarkConnect, which is a private list key to AWS. I want to have a failover using VPN gateway. As such, I'll be connecting to the dev and the prod environment. So as you add more and more VPCs, you have more dev and prod. As such, you have more and more VIPs being deployed. You start to have more and more DarkConnect ports being deployed as well. So let's say, for example, I want to connect all the yellow zones together. So we start to do peering. So I want to peer the dev and the prod. I want to connect the yellow environment now. So as you see, as it grows, it is not going to scale. So just imagine that I have another whole set of prod and dev coming up. How am I going to connect this? So it is going to be something like this, right? So it's quite challenging to manage it, and fairly quickly you hit certain AWS service limits as well. So this is where, in order to have connectivity option at scale, basically you only have two options. One is AWS Private Link, and the other one is Transit Gateway. Let's look at how does a Transit Amazon VPC will be translated using Transit Gateway. So what you have basically is central Transit Gateway with all the VPCs attached to that Transit Gateway. And you are just managing all the routes, just like how you manage the routes in the router itself. You control where it can route to. You have multiple routing domains within Transit Gateways. As such, you can control which VPCs can communicate with which VPCs. So let's take a deeper look in terms of Transit Gateway. So Transit Gateway basically is go by attachment. So you can attach a VPC, a VPN connection, as well as DarkConnect. So it has a concept routing domain. Routing domain basically is routing table. allows you to have more than one routing domain per transit gateways. It actually is up to 20. As such that you have multiple VPCs connecting to different domains depending on connectivity requirements. So starting from on-prem, I can have direct connect back to transit gateway, or for example, I can have VPN gateway that terminates at the transit gateway as well. You can scale to thousands of VPCs across Amazon accounts, right? For VPN connections, basically you can spread the traffic across many VPN connections. It doesn't have to be limited to a single VPN connection. As such, you're limited to 1.25G. It's flexible routing. Everything is just network interfaces in certain subnets in certain AZ. You control the segmentation and sharing based on the routing. So it's fairly easy, and you have a single pane of glass to see how does the traffic flowing between the VPCs. So as such, we come to start to realize that there are certain network design patterns that we see among our customers as well as internally on how we can make use of transit gateways. So typically you have development account, your testing account, production account, your certain shared services account, and of course on top of that, you have landing zone as well, as such as your logging account, security account. So all these things will govern all the different accounts within AWS. So now let's start to implement transit gateway as such that all these different accounts is able to see each other. And you can start to create multiple route tables as such that I do not want my development to see my production. I only want to see my testing to see my production. I want all the rest of the VPCs is able to see the shared services VPC. Then you have the hybrid connectivity back to on-prem using DarkConnect or VPN gateway. And here the interesting thing is that in the past, typically when you have certain application that is going outbound, we leverage on NAT gateway. That's the best practices that we propose as such. But then you start to have multiple NAT gateways. And NAT gateways actually cost money. So how do you actually help our customers to cost optimize this particular outbound connection? So now I have a single outbound VPC as such that all my VPCs will route through this transit gateway and go to this central outbound VPC as such that I can do proxy, I can do DLP on the traffic if I want to, and I can want to do certain URL filtering. As such, you have a central VPC that is going outbound. In addition to that, it makes it easier to collect all the logs as well, right? Instead of multiple NAT gateways, multiple firewalls across the different VPCs, now you have central location to collect all the logs. So now that's outbound. How about inbound? Likewise, I want to have a centralized inbound VPC as such that I want to place my network perimeter firewall there and WAF in a central VPC as such that all network traffic coming from the internet will go to this VPC, will hit the transit gateway, and based on the routing domains, it will know how to go back to the respective VPCs, right? And how do you scale the edge services? The common firewall today is able to do auto scale. In the past, you have that challenge to auto scale firewall. But now, most of the firewall brands out there today is able to do auto scaling as such that it doesn't matter how much traffic is coming in from the internet, it will base on the auto scaling and scale out your firewall. So with that, let me quickly show you a bit on what transit gateway look like. Before I go there, this is control tower, right? So control tower basically is almost like a centralized setup of all. It's a way to baseline your AWS account setup. You can start creating accounts within it as such that there's no need to create a separate account using credit card or what have you. You can define certain organization units as well. With organization units, you can attach different service control policies onto the OU as such that make it more restrictive in the production OU than the development environment OU. And by default, it comes with certain guardrails. So for example, I do not want on my production environment, for example, I want to enable certain guardrails, or these are all enabled. So let's go to the guardrails. I want to disallow. Okay, disallow access to IM users without IMFA. I want to apply guardrails on certain OU. Go to the production environment, and I'll enable get guardrail on those OU, as such that any users in account that's under this production OU, the IAM users doesn't have MFA will be rejected and will be flagged as non-compliant. So by default, Control Tower actually deployed 3 accounts. One is the master account. Then a log archive. This is where you are able to do a centralized logging and monitoring. And auditing account basically is containing all the CloudTrail logs, allows a user to go in based on certain access and look at all the different logs. So that's Control Tower in a short. So now, So now I have a network access central network account. This is where I will create all my network resources. So within it, I have the concept behind what I have here. Basically, what I'm trying to simulate is the connectivity effect from on-prem to AWS, but I want to do a north-south inspection. As such, I want to put a firewall between. I have an EC2 running in a VPC as to act as an on-prem. It is attached to the TGW, and that on-prem VPC basically running a Cisco CSR, having a VPN connections to the Transit Gateway as well. So where you see a Transit Gateway, basically, it's very simple. You see a Transit Gateway, pretty much that's it. You can see sharing. I can share a Transit Gateway across accounts. And based on the organization's settings that I have, I can say that this Transit Gateway can be only shared within the same organization. As such, that I will not able to allow another account that is not within the organization to attach to my Transit Gateway, because that will pose a scary risk. So everything is go by attachment. So for example, here I have a firewall for front door, as such that there's this attachment. Basically, all these 4 attachments basically is attached to the same Transit Gateway. I have a front door, I have an inside firewall, I have a customer gateway which is running a Cisco CSR. I have a production environment called Project 1, which is attached using VPC. As you see the rest, everything is based on VPN connections. So within it, you'll be able to see that there is a route table that you can leverage on. I can create multiple route tables. So with that, we can see whether the routes is being automatically propagated to the TGW and likewise to the VPN connection as well. So you can actually see that it's being enabled on both VPN, because when you set up VPN gateway, basically there are 2 tunnels, right? So one is active, one is passive. So once the Transit Gateway is set up, how am I going to share it across? So there's something called Resource Access Manager. This allows you to share firewall rules, Route 50 resolver rules, Transit Gateway, subnets, and what have you. So I have a TGW share here, as such that I'm only going to share it within the same organization. So it is pretty safe to say that there's no other accounts or VPCs from outside the organization is able to attach to this TGW. So within the EC2, I have a firewall as such that because through VPN, I have, and using a outer firewall, I can see that my routes from my VPC actually being propagated to my firewall, right? Likewise, from my firewall to TGW. And look at the BGP in terms of peering. Basically, I have 2 peer because I have 2 tunnels being peered. So this is basically how you set up the connectivity using a firewall, Transit Gateway, VPCs, and VPN. All right. So let's get back to the presentation. Oops. Okay. So now you have seen. So now I have, in addition to inbound, outbound, there are certain, based on certain compliance requirements or regulatory requirements, you are required to do certain east-west inspections. So same thing here. I have an inline services VPC that does east to west. I can put an IDS, IPS in between. I can put a firewall in between. And at the same time, I'm able to use these inline services for north-south inspection as well. So look at it, the amount of firewalls that you need to deploy basically actually goes down, the amount of VPC, the amount of administration overhead that you need to do in terms of patching all these firewalls and EC2 and what have you. Right. So next, we're going to come to VPC sharing. VPC sharing basically allows you to share a VPCs or the subnets to another different AWS accounts, as such that they're only able to leverage on the subnets to deploy their applications. They have no control on the networking components totally. So as such, they have central oversight of and control of all the network between that particular VPC. So within that VPC, for example, you could provide a hybrid connectivity back to on-prem, and no one can change that configuration. Okay. So just an example here. So it's still based on RAM, Resource Access Manager. I have certain external application accounts. I have a couple of internal application accounts. I have one VPCs, multiple public subnets, multiple private subnets. I have an internet gateway that I configure, which these external accounts will not able to change. I will provide a hybrid connectivity back to on-prem, and I'm going to control all the route tables between those subnets. And I'm going to share this with the external facing accounts. I'm going to share public subnets and the private subnets. So likewise, I'm going to share a private subnet with the internal application accounts. So as such that you can see, I can control how the application is being developed, how the network connectivity between the applications. This allows you to share certain resources as well. Let's say you have a common database subnet, you have multiple applications, multiple teams building on the same application, different components, but however, they need to interact with each other among the different components, as such that instead of having to do VPC peering, now you're saving on the VPC peering costs. Right? So the key thing is that you're decoupling the accounts and the networking components. You'll be able to leverage on lesser resources, higher density subnets, as such that you can attach additional 5-sided blocks to their particular VPCs. So when you do segmentation, this is something that what you want to consider in terms of how am I going to design my IAM policies? How am I going to segregate my security groups? Do I go with shared Amazon VPCs? Or I'm going to have separate Amazon VPCs because it gives me more control and also it's easier to manage. Having multiple VPCs in a single account, you have to leverage on the IAM policy to control who can access which VPCs in that particular account. You want to leverage on Transit Gateway to remove the scaling issues of VPC peering, VPN routes, the limitation on route tables, which is 1,000 or it's 100. And with Transit Gateway, the number of routes you can have in a single routing domain is 10,000 routes. So as you can see, it actually really scales up really well. Next, let's look at external connectivity. So this is no different VPN gateway, DarkConnect. You can deploy your own VPN on an EC2 if you want to, your Transit Gateway VPN. So in terms of scaling up, the only options basically is using DarkConnect and Transit Gateway VPN. So with DarkConnect, it gives you a private list circuit from a telco that you subscribe to, pull to DarkConnect co-locations. You can go for 1G or 10G ports, anything that's sub 1G, you can go with our DarkConnect partner. If you need encryption over this DarkConnect by default is only BGP peering only. Should you need any encryption on this particular tunnel, what you can do basically you can run VPN over this DarkConnect over a public VIF. So how to connect to many VPCs for DarkConnect? Basically, for redundancy purposes, you want to have 2 different lines, go to different DarkConnect co-locations. With that, you create a private virtual interface as such that you're able to see the VPCs that you're connected to through VGW. Subsequently, we have launched DarkConnect Gateway. DarkConnect Gateway allows you to have up to 10 VGWs per DarkConnect Gateway. And it's not only restricted to a single region. With DarkConnect Gateway, you can actually connect to multiple regions through a single DarkConnect line. as such that once you hit the DarkConnect gateway, you are purely on AWS backbone and go to a different region should you need to. And it supports multiple accounts as well, so you can share DarkConnect gateways across multiple accounts. So VPN with Transit Gateway, this is where you want to have encryption end-to-end all the way up to the VPC itself, right? So of course, as we know it, VPN bandwidth is limited to 1.25 G per tunnel. So how do you scale that up? What if I want to do hyper performance computing? What if I need a high bandwidth connectivity back to my on-prem data center for backend integration? VPN with Transit Gateway allows you to have multiple tunnels and using ECMP to share that tunnels and spread across the different tunnels. As such that we have tested it up to about 50 G. That is about like 50 tunnels, 40 tunnels. So that's the bandwidth that you can expect in terms of if you need certain high bandwidth VPN connection. As mentioned earlier on, this is you can have using ECMP to a multi-path BGP across the VPN. So now we have DarkConnect with VPN failover. This is one point of saving costs. We have also introduced something new. It's called Transit WIF. This is where for DarkConnect gateway to attach to the Transit gateway itself. So in the past, we only have private WIF and public WIF. Now we have Transit WIF specifically for attaching a DarkConnect gateway onto Transit gateway. Next, of course, you can run a VPN over DarkConnect over a public WIF. Right? All right. So that is on the server side. We also launched AWS Client VPN. Customers have been deployed their own VPN service on EC2 using OpenVPN client connecting to that EC2. It doesn't scale. What if that EC2 fail? How do I move the elastic IP to another EC2 as such that I'll preserve the elastic IP address? So this is where we launched Client VPN. As such, it's a fully managed service as well. You attach it to a VPC. Your users will just using an OpenVPN compatible client, connect to the client VPN endpoint, and that's it. Right? So it's a simple service that we have seen quite often customers using, deploying VPN software on using OpenVPN, OpenSWAN on EC2. Network services. So when you do a hybrid, by default, DNS is not resolvable between the on-prem and AWS, right? So what do you need to do? You start to deploy DNS forwarders on both sides, right? So you have rules on-prem that is pointing to DNS on the cloud, and on the cloud there's a DNS forwarders that resolve on-prem. And how do you scale? You add more DNS forwarders. You add some more. And how do you do across account? You start deploying DNS forwarders across all the VPCs. You start deploying even more as you scale. So this is where we come up with Route 53 resolver. As long as your VPC is attached to a private hosted zone in Route 53, you are able to create a Route 53 resolver endpoint as such that all the VPCs to resolve any DNS will point to this endpoint, right? This endpoint basically is powered by AWS Private Link, as such that you can create conditional rules. Any domain name that is on-prem will be pointing back to on-prem DNS to resolve, and likewise from on-prem servers pointing to this Route 53 resolver endpoints to resolve any DNS or fully qualified name on AWS. So this is basically how it works. It can be based on a single ENI because it's a private VPC endpoint. And to scale, you can create additional endpoint across multiple subnets across AZs, right? So instead of having a single place of rules and to configure multiple times, you can actually share these rules across multiple AWS accounts and multiple VPC as well. As such, you're able to centrally manage this, all the DNS resolver. So we have three types of VPC endpoint. One is VPC endpoint as you know it. We have DynamoDB, S3 as such that you are able to access these services privately without going over the internet. Over time, we have launched a lot of number of AWS services that support private endpoint as such that, especially for secured application environment, as such that, for example, your intranet zone will have no internet connectivity to the internet as such that, but still I want to leverage on all these services. So the only way to do it basically is through private endpoint. But how do you scale? Across AWS accounts, you see a pattern as such that customers start deploying multiple endpoints to each individual VPC across AWS accounts. And each endpoint, each ENI costs money as well. So how do you optimize this? Instead of having all the ENIs, all the endpoints across AWS account or across VPCs, you centralize it across a single VPC. And using Transit Gateway, you're able to route it to a single endpoint. Right? So last but not least, multiple region. I'm going to skip this really fast. I've only 2 minutes left. So this is more in terms of for inter-region peering. You can leverage on VGW, VPN inter-region peering today. TGW support inter-region peering in the future. But this is more in terms of using a DarkConnect gateway to connect to multiple regions. You could be having a highly redundant application that you deploy across regions, leveraging on DynamoDB global database tables or multi-master of Aurora. You can actually leverage on this connectivity to deploy across multiple regions. Of course, in the future, Transit Gateway as well. All right. So key takeaways, be flexible in terms of how you architect today. Start small, start simple. You scale it, you tweak it, you change it. It's never one size fits all, and it's not never one end and everything is done. You keep iterating and look at what is required in your AWS accounts and your networking environments. With that, thank you very much. All right. Please complete the survey. Thank you.
Thank you very much, Steve. And like he said, please complete the survey in the app, and you can use that to get a free AWS branded item. And at this time, we will have a 10-minute break, and then the next session will be the VMware Cloud on AWS, starting at 4:15. If you would like the slides for this session, you can scan your badge right at the front here. Thank you.